All right, welcome back. We're going to talk a little bit more about standard form. We did some things with this specific case example, 2x minus 3y equals 4. We would like to figure out in general how we can get our y-intercept, which has an x-coordinate of 0, our x-intercept, which has a y-coordinate of 0, and our slope. If we start with the generic equation ax plus by equals c, where a, b, and c are integers and a is greater than 0. Okay? So, let's start off by getting rid of the specific stuff and looking at what is going to happen if x is 0 in this original equation. We're left with by equals c. Okay? So, by equals c when x equals 0. Solving for y will be c divided by b. To get b times y to become just y, we have to undo multiplication. Undoing multiplication means you're going to divide. So if we divide both sides by b, we get c over b. And the b's cancel here. B divided by b is 1, so those disappear, and we're left with y equals c divided by b. All right, so if you have an equation in standard form for a line, you know that it's crossing the y-axis at 0, c divided by b. This is our y-intercept. Right here. Now, our x-intercept, I'm going to get rid of this stuff here. Our x-intercept happens when our y-coordinate is 0. We're not above the x-axis, we're not below the x-axis, and so when y is 0 in our original equation, we'll get ax plus b times 0 is 0 equals c. Okay, so ax plus nothing equals c, so ax equals c. And again, to get x alone, we'll divide by a. The a's will cancel. We do the same thing to both sides of the equation. Now we've got x equals c divided by a. And just like that, no matter what our equation is, if it's written in standard form, we can give our y-intercept this way, our x-intercept this way, and if we look down at our slope, with our original numbers, we ended up with the slope equaling 2 divided by 3. Okay, that was when we had 2x, recall, 2x minus 3y equaled 4. I'll write that back up so you know what our numbers were. Notice 2/3 uses these numbers 2 and 3, but the sign is different, right? If I divided a, which is 2, divided by b, which is -3, I'd get -2/3. But my slope is actually the opposite of that, okay? So I could generalize it this way and say that the slope, m, slope is m, equals negative a divided by b. Now, don't just take my word for it. Let's actually rearrange this into the form of an equation which includes our slope, y equals mx plus b. All right, let's do that over here, and I'll get rid of all this junk. All right, so if we start with ax plus by equals c, and we want to solve for y, get y all by itself, let's see what happens. We'll need to move ax to that side, so I have addition. In order to undo addition, we'll subtract. So we go by equals c minus ax And then if I want y alone, I'll divide by b. And I'm gonna flip-flop these. This is c plus negative ax. Addition is commutative, so I'll put negative ax plus c. And then I'm dividing by b. Now, this is almost that form. Notice this one isn't written as a fraction, so I'm going to have to rewrite this as two different fractions. I've got negative ax divided by b, and I've got c divided by b. Common denominator lets me either combine or break apart like that. And this one, I'm almost there. I've got something times x divided by something. Well, I could do the division before I multiply, so I can say negative a divided by b times x plus c over b. And notice, there's my slope. Slope is what I'm multiplying by x. Negative a over b, that's what we found when we generalized our specific problem earlier. And also, notice, plus this fraction, c over b, that number, whatever that constant is the y-coordinate of our y-intercept. Notice that's right here. We found that earlier. When x is 0, this whole term cancels, and I'm left with y equals c divided by b. Now c and b are constants. So this fraction is equal to b in this other form. Okay? So, if you have a linear equation in standard form, you can pretty quickly figure out what the x-intercept is, what the y-intercept is, and what the slope is. Once you have those things, you could rewrite it in slope-intercept form, or you could pick one point that you know and use the slope that you found and write it in point-slope form. And that is it.